gigantic steel frame called a gantry would be needed to house the hull as it grew. It would have to be the biggest of its kind. Historian Jennifer Regan has come to see what's left of it with Una Riley of the Belfast Titanic Society.
So Una, we've left Harland and Wolff headquarters, and that's where the idea happens. And that's where the plans are drawn. And then this is where the construction happens.
Yes.
Right? Where are we?
We're actually standing on the slipway where the Titanic was built. It was actually built in that area there.
The gantry that surrounded her was over 800 feet long and twice the height of the Lincoln Memorial. Today, only traces of this massive structure remain.
And you can see the stumps of the gantries over here.
These metal bits sticking out here.
These metal bits. Now, and they would have risen hundreds of feet in the air.
So this area we're standing on right now, which is, I mean, it's kind of a wasteland in a way.
It is, it is.
This would have been all structures, and this would have been hundreds of people.
Yes, I mean, this would have been an anthill of activity. There would have been men scurrying about on top of these huge big gantries, working cranes, riveting. So this would have been an incredibly noisy, dangerous area.
The gantry dominated the Belfast skyline for 6 decades. It had 16 movable cranes, lifts, and walkways. It weighed over 6,000 tons. Rupert Kayser has come to talk to one of the men who worked beneath it, former ship worker George McAllister.
It must have been a very awe-inspiring sight for people who come here for the first time and see this colossal, great lattice work of metal and these 2 ships forming underneath it.
Well, I came in here as a 16-year-old boy, and I was amazed at the noise and the number of people, the number of men working in this particular area here alone.
The deafening sound of the shipbuilders at work could be heard across the city.
That is the first thing any visitor would hear, was the noise of the plates being hammered and the riveting. The riveters were riveting all day long with hammers, just hammering on a steel box. Those boys came out stone deaf. There's no doubt they came out stone deaf.
They had no ear protection or
no ear
anything
protections,
like
no safety boots, safety toe cap boots, no gloves, no helmet, nothing whatsoever.
By 1910, Harland and Wolff were employing 15,000 workers to build the Titanic, alongside her sister ship, the Olympic. They used tried and tested methods. First, they would lay a keel. Then, they'd build a frame on top of it. The frame was then clad in a steel shell. Tens of thousands of tons of steel were poured, rolled, and shaped. They were cut on site into plates 30 feet by 6 feet, and then delivered to the gantry along a network of railroad tracks. When these plates were in position, construction would begin. The shipyard is littered with the relics of this process.
Looking for clues, you're asking for clues. Let's have a look in here. We'll dig this up and we'll see. Here we are. Here we're getting pieces here, look, see. There's a piece of a rivet.
Interesting, that is.
There's another little piece of a head of a rivet. And here's nuts and bolts, a plate washer on the temporary nut.
And is it likely that that any of these items could have been used to build the Olympic and Titanic?
Well, this is the slipway that the Titanic came off. I cannot guarantee you that they came off Titanic, but one never knows.
Sure.
Over 3 million of these rivets were used to hold the hull together. Further clues can be found in the maze of railroad tracks, which an army of 50 small cranes used to travel around the shipyard. 3 of the cranes still stand. They were powered by steam.
Yeah, those 3 cranes are the last of the steam cranes that's left here in Harlands. They were here at the time of Titanic. They helped to build Titanic.
When George McAllister worked here in the 1970s, he operated a crane just like this one.
And that's the old boiler behind you there, but and made the steam. And he operated these levers for lowering the jib.
These cranes were the workhorses of the shipyard. Able to lift 5 tons and using tried and tested technology, they were extremely reliable. The simplicity of their design meant that they would remain in service for decades.
It's amazing to think that these cranes, once helped build this legendary vessel, and they're just sitting here, rotting away.
It wasn't just the machinery that had to be resilient. For the men building the Titanic, conditions were tough.
Well, when the shipyard first started, when it first opened in the 1800s, the men worked from 6 o'clock in the morning to 8:15 at night, 5 days a week.
It's 14 hours a day.
And from 8 o'clock in the morning on a Saturday to 4 p.m. It was a dangerous job to be done. There was lots of injuries, such as bits of riveting flying off boats, maybe falling off the top of the ship, men working down below. Well, you just had to carry. In those days, they were glad of a wage, so they just had to carry on with it.
Harland and Wolff were tough employers. The shipyard workers had very few labor rights.
Men lined up every day trying to get a day's work, and in fact, if you got a day's work, you used one of these little boards.
What's this?
Which is a little wooden board, and it has a unique number stamped in there.
35315.
Right,
Okay.
and that number would have entitled you to this little board entitled you to many things, even the permission to go to the toilet.
You had to use
You had
that.
to use that, and you were only allowed 7 minutes all day in the toilet.
There were hundreds of different trades and thousands of skilled craftsmen at work in the shipyard. From riveters, steelworkers, fitters and joiners, to plumbers, cabinet makers, painters and plasterers.
I mean, it was a whole world of industry.
Thousands of people.
Thousands of people all working together to produce magnificent ships.
So what you're describing is not just the building of a ship, but it's the building of a city around this shipyard.
It was like a city, and they did look after their citizens. Yes, they were tough employers, but there was respect there. It was tough, and the men were tough, but they produced some fantastic ships.
It took 15,000 men, 24,000 tons of steel, 3 million rivets, and 2 years of work. Finally, the hull was ready to be floated.
Now tell me about the day of the launch, because we know that some 10,000 people showed up here, but actually they were just launching the outer shell of the boat, right?
That's true. The ship was built here, basically the hull, and it was into these waters here. The Titanic would be launched on that day, 31st of May, 1911.
The hull's entire weight rested on rows of wooden supports called pit props. For the ship to enter the water, these props had to be knocked away by hand. To find out more about this highly dangerous procedure, marine engineer Rupert Kayser has returned to the Titanic slipway with George McAllister.
Now, she's the largest ship in the world. It must have been an extremely dangerous time with this huge vessel towering above and knocking away all the wooden supports. I mean, was it really that dangerous?
Yes, it was very dangerous because those pit props, as we call them, were flying everywhere.
Right.
So you could have got a leg broke. People could have been killed, which they were.
Were they flexing under the weight?
Well, as they got so many out, the ship was coming down onto the rest that was left there, and they were actually bowing out, and they just shot out at a tremendous force.
Shot out?
Shot out anywhere.
At exactly 12:14 p.m. on May 31st, 1911, after final checks, and with a signal from Lord Peary, the Harland and Wolff chairman, the launch began. It was a dramatic moment. Titanic was in motion for the first time. It took just 62 seconds for the 24,000-ton hull to move down the slipway into the River Logan. For the people of Belfast, this was a time of pride, achievement, and hope. But it came at a cost. One of the team assigned to remove the pit props was crushed by falling timber. He died. The Titanic had claimed a life before she'd even entered the water. After the launch, work began immediately on equipping the hull. As well as huge steel anchors, 4 mighty funnels were fitted. Only 3 of them had any practical purpose. The 4th was there just to make the Titanic look as impressive as her rivals. 2 massive steam engines would power her across the Atlantic. They were fed by 29 boilers and 159 furnaces. When the Titanic sailed, 160 firemen would stoke them with over 600 tons of coal every day. The 2 engines each stood over 30 feet high. In their time, they were the largest ever built. Their design was very similar to that of these smaller engines, housed in a museum in London. Rupert has come here to see the engines in action and find out from steam engineer Dick Fillery what it must have been like in the Titanic's engine room.
This engine here is, in fact, quite a small triple expansion engine. The engines in the Titanic would have been, what, 5 times the length, 4 times as high. Instead of just one walkway round it like this, there'd have been 3 or 4 walkways going up right up the very top of the engine. And apart from that, it would have been dark and gloomy inside the boiler rooms. They didn't have lots and lots of light going, so this thing would tower up into the darkness and make it be even bigger than it appeared. And of course, the engine would be turning around, and in fact, the whole ship would shake as the engine was turning. So some people found it quite a scary place to have been.
The design of the Titanic's engines was comparatively old-fashioned. While the rival Cunard Line had fitted their ships with turbines, the Titanic's builders put their faith in a traditional reciprocating design.
So why was an engine of this type used to propel the Titanic?
They were efficient, they used less fuel than a simple engine, and also they were well-tried technology. They'd been built for years, people knew how to put them together properly, people knew how to run them properly, and they were reliable. And that was what a shipping company likes.
The Titanic did, however, have an auxiliary turbine engine, powered by the exhaust gases of her 2 main engines. This drove a 3rd, central, 4-bladed propeller.
That's a little strange because at the time, ships had either reciprocating engines or turbine engines.
Yeah.
Why the combination?
It was going for efficiency. One of the things you've got to do, once you get in a ship, you've got to carry your fuel with you. So the less fuel you can carry, the more passengers, cargo or whatever you can carry in a boat.
With the engines fitted, the Titanic needed to be moved out of the water into a dry dock, where all the final work on the hull could be completed. The only dry dock that could accommodate her was the Thompson Dry Dock. Rupert has come here to meet naval historian John Beattie from the Belfast Science Park.
This really is quite an extraordinary sight. Absolutely colossal size. It really does take your breath away. It's fantastic to look at.
Yes, indeed, the dock was totally filled by the Titanic.
This was the largest dry dock of its time, 850 feet long, equivalent to 3 football fields, and 120 feet deep. To build a dry dock on this scale was an incredible engineering feat.
Well, there really must have been some huge undertaking to create a dock of this size, especially 100 years ago.
Yes, indeed. They knew at the outset that they had a very big challenge to build this dock, as they were building through very poor material, approximately 50 foot of reclaimed land, which is basically mud. And indeed, the dock itself, hidden where you cannot see, there's an enormous amount of materials used in the dock. Absolutely stupendous amount of concrete and brick.
So it really was a colossal engineering feat.
It was, and a high-risk piece of engineering.
The aim was to build the dry dock in 3.5 years, but eventually it took 7 years. It was ready just in time for the Titanic. On February 3rd, 1912, tugboats began the delicate process of maneuvering the Titanic into the Thompson Dry Dock. When she was inside, the gate was closed and the engines from the nearby pump house began to drain the water.
In the case of the Thompson dock, it's 23 million imperial gallons of water have to be taken out to dry the dock.
23 million.
23 million. And these pumps could pump all that water out in 1 hour, 40 minutes. But in real terms, they would be more careful in how they pumped the water out because they had to allow the ship to settle onto the keel blocks.
In the Titanic's case, pumping lasted 12 hours.
The operation was made more complicated because of the extraordinary length of the Titanic and the extreme value of the vessel. They were extremely careful that the 55,000 tons would settle precisely on the keel blocks. They didn't want to take any chance that they would damage the vessel as they bedded it down and dried it out.
The final stages of construction could now take place. Fitting her mighty 3-blade propellers, wiring the ship's state-of-the-art electrical systems, and finally, painting the hull. By March 1912, the main structural and engineering work was complete. Now, the challenge was to fit out the interior and transform the Titanic into a floating palace. No expense was to be spared in making her the most luxurious liner ever built.